Ready to dive deep into Ethereum. We're taking on grokking Ethereum today and really getting into the nitty-gritty of this tech.
It's more than just a surface-level look. We're talking about how it works, why it matters, the whole shebang.
And I think a perfect place to start is with one of the core concepts. This book nails decentralization.
Absolutely. And grokking Ethereum doesn't just throw that word around. They actually show why it's so important. That story about Sophia and her pub? Genius.
Right. Sophia's pub, such a clever way to explain how even a system that seems stable can be super vulnerable.
It shows what can happen when everything relies on one central point, Like with Sophia's whole drink now, pay later system. At first, boom, business is great, but
then it all goes south when she can't collect those debts.
Yeah.
Suddenly that one weak link throws the whole system out of whack.
Exactly. And it's not just her, it's the suppliers, the bank, everyone feels the ripple effect. Suddenly, this idea of decentralization, of spreading things out, it becomes really appealing.
It's like you don't want all your eggs in one basket,
yeah.
right? So how does Ethereum address this?
Well, the book emphasizes that decentralization isn't just a yes or no thing. It's more nuanced than that. They break it down into 3 axes: architectural, political, and logical.
Okay, so let's unpack those. Architectural decentralization, that's about how the system is actually structured, right?
Exactly. Think of a spider web. You can take out a few strands and the whole thing still holds. Architectural decentralization means the system can handle it if a few parts fail.
So even if some computers on the Ethereum network go down, the network itself can keep chugging along.
Exactly. Now, political decentralization, that's all about control. Who's calling the shots? A politically decentralized system means there's no single entity with absolute power.
So even the Ethereum Foundation can't just wake up one morning and decide to change all the rules?
Nope. They can propose changes, sure, but it's up to the entire community, all those distributed users, to decide if they want to go along with it.
That makes sense.
No.
So where does the logical axis fit into all of this?
Here's where it gets interesting. Because Ethereum, even with its decentralized architecture and all that, is actually centralized on the logical axis.
Hold on. How does that work? That sounds kind of contradictory.
Think of it this way. Ethereum has thousands of computers, right? But they all act together like one massive computer. The book uses figure 2.3 to help visualize this. Each computer is doing its own thing, but they come together to create this single unified thing.
So it's like this giant globally connected computer, but how do we actually interact with it? Grokking Ethereum talks about this whole ecosystem of tools. We've got the Mist browser, dApps, something called middleware. Where do we even begin?
It's like, showing up in a new city for the first time. It can be a little overwhelming, but once you get a feel for the layout, how everything connects, it's not so bad.
Okay, so let's start with something familiar, the Mist browser. This isn't just a regular internet browser, right?
Not exactly. Think of it more like your entry point to this whole decentralized world, specifically for these things called dApps. Like, how you use an app store on your phone? You go there, download apps, all that.
Yeah, like the App Store or Google Play.
Exactly. Mist is similar, but instead of connecting you to a central server, it's your direct link to the decentralized web.
So it's like the App Store, but for dApps built on Ethereum.
You got it. It gives you access to this whole universe of applications, each one doing its own thing.
And speaking of dApps, the book uses this analogy. I love it, like dishes at a potluck.
Perfect comparison.
Yeah.
Because a lot of these dApps are open source. That means anyone can look at the code, mess around with it, even use it to build their own dApps. It's this big collaborative buffet of decentralized tech.
I can see how that open source aspect really ties into that whole decentralized idea we were talking about earlier. No single person controlling everything. It's a group effort.
Absolutely. Now let's move on to this middleware layer. This is where things get really interesting. The book focuses on 3 key components: Swarm, Whisper, and the EVM.
Okay, break those down for me. What is Swarm all about?
Remember how we were talking about decentralization being important? Well, that goes for data storage too. Swarm, that's Ethereum's way of doing decentralized storage, meaning those dApps aren't reliant on some central server that could crash or get censored.
So instead of my data living on some company's server farm, it's spread out across the whole Ethereum network. Sounds incredibly secure. And also ridiculously complicated. How does that even work?
It's all about breaking data into these manageable chunks, kind of like digital puzzle pieces. Each piece gets a unique identifier called a hash, and all those hashes get organized into this thing called a Merkle tree.
Okay, so is the Merkle tree like a map then? Helps the system keep track of all these data chunks?
You got it. That's what makes swarms so resilient. Even if some of those data chunks get lost, the Merkle tree helps the system piece the original data back together.
Like a digital safety net for information. That's wild. Okay, on to Whisper. What's so special about it?
Whisper? Well, that takes privacy to a whole new level. We're talking about a messaging protocol that doesn't just protect what you're saying, but also hides the fact you're even communicating in the first place.
Wait, so you mean it doesn't just scramble the message itself, but hides who's talking to whom, all of that?
Yeah, exactly. There's this great analogy in the book. Imagine you live next to a train track, right? You can figure out a lot just from the vibrations, yeah. When the train's coming, how heavy it is, you learn things without even seeing what's inside.
So Whisper is like building those train tracks underground. You get rid of those telltale signs, make it near impossible to tell if a train is passing by at all.
Exactly. Of course, this level of privacy comes with a small price. Whisper focuses on security so much that sometimes you lose a bit of speed and have less bandwidth. But when privacy is key, it's a total game changer.
Makes sense. Okay, we've covered Swarm for decentralized storage and Whisper for super private messaging. Now, what about that last piece, the EVM? What's its role?
The EVM, or Ethereum Virtual Machine, that's where the real magic happens. It's what brings those smart contracts we keep hearing about to life.
So it's like the engine behind all of Ethereum's smart contract capabilities.
Precisely. The EVM takes the code of a smart contract and makes sure it runs on the blockchain securely, predictably, and separately from any other programs.
Predictably, what does that mean exactly?
It means no matter what, given the same input, the EVM always spits out the same output. Doesn't matter which computer on the network is running it. That predictability is super important because it builds trust in a system where you don't necessarily know what or who is running the code.
Makes sense. People need that consistency to trust the smart contract's rules will be followed no matter what. How does it even handle all that code, though?
Well, it uses something called a stack-based system. Sounds complicated, but it's pretty cool. Imagine a stack of plates. You add instructions on top, and the EVM just works through them one by one from the top down.
So it's a very systematic and organized way of doing things. Okay, so the EVM keeps everything running smoothly, make sure things happen how they're supposed to. But we still haven't talked about the real stars here, the smart contracts, what makes them so smart, and how does the EVM actually execute all their instructions?
Well, the smart part comes from their ability to basically act as their own enforcers. They make sure agreements are followed automatically, no middleman needed, makes everything faster, more transparent, the whole 9 yards. And that's where this idea of Turing completeness comes into play.
Turing completeness. Honestly, that always sounded a bit intimidating to me. What does it even mean when we're talking about Ethereum and these smart contracts?
Basically, it means that the language used it can handle any kind of computation that a theoretical, all-powerful computer could. So you've got incredible versatility, real power when it comes to defining how a smart contract behaves.
So basically, you can code it into a smart contract with this Turing complete language.
Theoretically, yeah. But for Ethereum, the key takeaway with Turing completeness is that it can work with loops.
Loops, so like repeating a set of instructions multiple times. Why is that so important?
Efficiency. Flexibility. Let's say your smart contract needs to do a simple multiplication. Without loops, you're stuck writing out the addition like a zillion times. But with loops, just tell the code, hey, do this thing this many times. Way more concise, way more adaptable.
So they're like these little efficiency hacks built into the language itself. But Grokking Ethereum mentions some downsides to loops too. What's the catch?
Good point. Loops can be powerful, but also a bit of a double-edged sword if you're not careful. Remember, every single thing you compute on Ethereum, that takes up resources, do too much, and it can strain the whole system. One badly designed loop running wild, that could bog things down for everyone.
A trade-off then. Power versus responsibility, right? And that's where gas comes in, I'm guessing.
Bingo. Gas, that's Ethereum's way of dealing with this whole challenge. Think of it like fuel for all those computations happening on the blockchain. Every single thing a smart contract does, that takes some gas. More complex stuff. You're going to need more gas.
And like in the real world, you got to pay for that fuel.
You got it. Ether, that's the currency you use. More gas. Your smart contract guzzles. The more ether it'll cost you to keep it running.
So it's not just about cost either. It incentivizes writing good code. Make sure people don't go overboard with these loops and crash the whole system.
Exactly. Now, switching gears a bit, Grokking Ethereum also dives into some juicy Ethereum history. The whole ETH versus ETC thing. Heard of this?
Vaguely. Something about a hack, right?
Oh, yeah. Big time. Goes back to the DAO, this decentralized autonomous organization. Basically, imagine a venture capital fund, but it's all run by a smart contract, totally decentralized. Problem was, there was a vulnerability in the code.
Uh-oh.
I was right. Group of hackers found that vulnerability, exploited it, and made off with a ton of ether.
That must have been a huge deal for the Ethereum community.
Total earthquake. The question became, what do we do about this? The community was split. Most people felt like, look, this hack goes against the whole point of the DAO. Those funds should be returned. So they proposed this thing called a hard fork, basically hitting rewind on the blockchain to before the hack.
But I thought blockchains were supposed to be unchangeable. Like once something's written, that's it.
Ideally, yes. And that's what the other side of the argument was all about. Smaller group, but they felt strongly that you don't mess with the blockchain's history, even if it means the hackers win.
So it became this whole philosophical debate. Justice versus staying true to the code. Fascinating.
Right. Ultimately, the hard fork won out, led to two versions of Ethereum, ETH, which continued on this updated, rewound blockchain, and ETC, Ethereum Classic, which stuck with the original unchanged version.
Wow, a real fork in the road. Each path representing a different way of seeing things. This has been eye-opening, really digging into Ethereum like this. It's way more than just a cryptocurrency. It's a whole movement, a philosophy, part of history even.
And we've barely scratched the surface. But grokking Ethereum, it gives you such a solid foundation to build on. As you keep learning, think about how this stuff, this decentralized tech, could change things for you, for your work, even the whole world. What problems could it solve? What possibilities does it open up? Those are the questions to keep asking as we explore this exciting new frontier.
Couldn't agree more. This has been a wild ride, and I'm definitely hungry to learn more. A huge thank you to you for breaking it all down, and to everyone listening for joining us on this Ethereum deep dive.